Hello friends, welcome to Road to IIT. Let's discuss the brief of thermodynamics chapter today. So, thermodynamics. Okay. So let's discuss all the basic things as we learn the important formulas, the important subjects, the for numericals based on thermodynamics. So in this last video we are going to just review the whole chapter once again. Okay, so first of all we are starting with the basic thing, that is heat. We all know delta Q. First of all, it's a path function, important to notice. That means it's depend on the path. If it flows through various path, then for the same end limits like this, if the path is different, the value of heat may be different. Okay, so this is heat. Okay, it is the internal, it is the energy that is transferred between a system and its environment because of temperature difference between them. Heat is a path dependent quantity. Now we have two type of heat. For the gases, when heat is absorbed, temperature changes. Okay, for the gases, when heat is absorbed, the temperature changes, and the amount of heat is Q is mu C delta T, or we can say mc delta T. Now if at constant pressure, if we talk about constant pressure, then delta Q at constant pressure is equals to mCp delta T. Here Cp is specific heat at constant pressure. If we talk about constant volume, delta Q V, then it becomes mCv delta T. And here Cv is specific heat at constant volume. Okay, so this is also important thing to notice here. Now the second thing is internal energy. This is the first important thing. The second thing is internal energy, that is delta U. Okay, now what is delta U? Internal energy of a system is the energy possessed by the system due to molecular motion and molecular configuration. That means each and every system has their own molecular structure, and due to their structure, molecular configuration and molecular motion, the energy possessed by the object, by the system, is known as internal energy. Okay, the energy due to molecular motion is known as kinetic energy, UK, and energy due to molecular configuration is known as internal potential energy, that is UP, and U total is equals to UK plus UP. This is total U. Okay, for an ideal gas, there is no molecular attraction. That means UP is equals to 0. Okay, so that is it about the internal energy. Now another important term is work done. That means work delta W. What is work done? Suppose we have this much piston cylinder arrangement here. If we have piston cylinder arrangement, and if cylinder moves to distance x, or we can say dx, then there has to be some work done, as the volume is going to be changed. Let's suppose that volume is going to change from V1 to V2. V1 is initial volume, V2 is final volume. Let's say volume is going to change from V1 to V2. So the amount of work done, W, is equals to integration V1 to V2 P dV. That means you can say that P V1 minus V2. Okay, there is also a path function. This is important to notice. This is path function. That means it depends on path also. Please make sure that internal energy we just discussed, delta U, is not a path function. It's point function. That means whichever path you follow, if you go through this to this point by this way, by this way, or by this way, or by any other way, the change in internal energy from this to this point will be same. It does not depend on the path. Okay, please make sure that. Okay, let's discuss some important formula for work done. Okay, if we have PV diagram like this is P, we have PV diagram like this. So what will be the work done? Work done is area under the curve. So this will become your work done. So let's say this pressure is P and this volume is V. So the work done becomes area is equals to work is equals to P into V. Okay. If you have process like this, this is say the end limit of pressure and this is end limit of volume. In this case, again, area under the curve is will give you the work done. So it becomes P V2 minus V1. Okay. If we have process like this, PV diagram, volume is constant, so the work done is 0. Constant volume work done is 0. Okay. Now some thermodynamics law. The first one, Zeroth Law of thermodynamics. Zeroth Law of thermodynamics. What is Zeroth Law? If system A and B are each in equilibrium with a third system C, then A and B are in thermal equilibrium with each other. That means if this is system A, this is system B, and this is system C. If A and C are in thermal equilibrium, if B and C are in thermal equilibrium, then we can say that A and B are also in thermal equilibrium. Okay, so this is the zeroth law of thermodynamics. Zeroth law of thermodynamics. Law of thermodynamics leads to the concept of temperature. This rule leads to the concept of temperature. Okay. The next law is first law of thermodynamics. First law of thermodynamics. It is a statement of conservation of energy in thermodynamic process. It is nothing but conservation of energy. That means delta Q is equals to delta U plus delta W. That means according to heat given to a system, delta Q is equal to such sum of increase in internal energy and work done by the system against the surrounding. Okay, so this is also most important law of thermodynamics. In this we must have to use a sign for each and every quantity, that is delta Q, delta U and delta W. Let's say the quantity we have delta Q. We have to use the positive sign when heat is supplied to the system. When heat is supplied to the system. When heat is supplied to the system, we need to use the positive sign. We are going to use negative sign when heat is drawn from the system. When it is drawn from the system, we have delta W as well. If when work done by the system, we are going to use positive sign. But if when work done on the system, we are going to use the negative sign. And for delta U, if we talk about delta U, positive sign when temperature is increasing, we are going to use positive, and negative sign when temperature is decreasing. As we just saw that delta U is the proportional to the temperature difference. So if temperature difference is positive, we are going to use positive sign. If temperature difference is negative, we are going to use negative sign. So this is sign important thing, how to use full sign convention in the thermodynamics. So this needs to be remembered. Now again, the various type of processes that we learned in the numericals, we saw the basic problems of each of every types of process. Let's revise all the processes. First process, isobaric process. Isobaric process, tell me guys, isobaric process, P is equals to constant. P is equals to constant. If P is equals to constant, that means V is proportional to T. That means V1 upon T1 is equals to V2 upon T2. Okay. So what will be the indicator diagram? This is known as a equation of state. This is known as equation of state. What will be the indicator diagram? That means how we are going to indicate this process. Indicated diagram. P, phi. This is indicator diagram. Pressure is constant, like this. Okay. This is an indicator diagram. Temperature increase, so U is positive here. Temperature is going to increase, so delta U is positive. Here volume is increasing. Volume increase, you can see that simply volume is increasing. So delta W is also positive. And if both are positive, then delta Q is also positive according to the first law of thermodynamics. Simple. But this follows if we are heating, or we can say that in the expansion process, heating or expansion. That means like this diagram we follow. If we follow this diagram, I mean the reverse path, you can see volume is decreasing on volume scale. If this is going to be follow, the sign changes. So each and every sign will change now. This becomes negative, this becomes negative, and the whole delta Q becomes negative. Okay. So this is also important thing to remember. The next thing is next process we are going to see. Next process. Okay, work done. Work done also need to remember. Work done is equals to simple P final volume minus initial volume. So this is all about isobaric process. Let's check one more important process, that is isochoric process. Isochoric process. Isochoric process, that means volume is equals to constant. If volume is equals to constant, then pressure is directly proportional to T. That means P1 by T1 is equals to P2 by T2. This will become your equation of state. Indicator diagram. PV, perpendicular line to the x-axis, that means volume scale. So here delta W will become 0. Why? Because volume is constant. If volume is constant, delta W becomes 0. So delta Q is equals to delta U. That means the heat supplied or heat rejected becomes the change in internal energy. Okay, the next process is isothermal process. Isothermal process, that means temperature is going to be constant. If temperature is constant, then P is inversely proportional to V. That means P1 V1 is equals to P2 V2. This will become the equation of state. The indicator diagram for isothermal process is like this. I am drawing the various diagram as per different temperatures. This is indicator diagram for isothermal process. Here, this is T1, this is T2, this is T3, and T1 is less than T2, less than T3. Okay, so this is the isothermal process, and this is indicator diagram for isothermal process. Now, for isothermal process, specific heat, there is no temperature change. Delta U is 0 here. Please notice, because delta U is function of temperature change proportional to delta T. Delta T is 0, so delta U becomes 0, delta U 0. That means delta Q is equals to delta W. Now delta U becomes 0 here. Okay, so work done here in this case, work done is equals to integration V1 to V2. We need to derive the formula P dV. If we put P as C by V, as PV is equals to constant, so P becomes C by V. If we put here and integrate, we got the work done formula mu RT log with the base E Pi by Pf. That means pressure initial upon pressure final. Or we can get the same formula in the form of volume also, mu RT log with the base E Vf by Vi. So this is the formula of work done for the isothermal process. Please do remember this, guys. Next process is adiabatic process. Adiabatic process. In adiabatic process, heat transfer is 0. That means delta Q is 0. Heat transfer is 0. In the equation of state, it is PV raised to gamma is equals to constant. Indicator diagram. Okay. Using this, we can derive the relationship between PV also, P and T also, and V and T also, by using the ideal gas equation PV is equals to MRT. This is very simple. If you want to find the relationship between P and T, just put V is equals to MRT by P here, and we eliminate V and got the equation in P and T. Okay, this is a very simple thing. In this case, specific heat delta U is mCV delta T, and then the work done. Important thing is work done here. Work done, guys, please do remember Pi Vi minus Pf Vf upon gamma minus 1, or we can say that mu RT Ti minus Tf upon gamma minus 1. This becomes this using this relation, ideal gas equation. Okay, So please remember this also. Now some other formulas to remember. Ideal gas equation, as we know that PV is equals to MRT for ideal gas. PV is equals to mu RT, or we can say that MRT. This is for ideal gas. Please also remember this. Then this is also important thing to remember, quasi-static process. One type of reversible process, very slow process. If you wanna get the example, this is such a process that add one point of sand at every particular integral, every particular interval, small amount of sand, and this piston will move down very slowly down to the cylinder, and this process will become a quasi-static process. Okay, then heat engine. This we also learn, heat engine. What heat engine will do? Heat engine is a device which converts heat into a work continuously through a cyclic process. That means it takes the heat from a T1 temperature, high temperature source. This is heat engine. It delivers some amount to the sink that is at T2 temperature and give us some amount of work done. Okay, and here this work done becomes Q1 minus Q2. This is Q1 and this is Q2. We all know that. A very simple thing here. Here the efficiency of heat engine is Q1 minus Q2 upon Q1 is equals to 1 minus Q2 by Q1. Okay, so please remember this also. Then the next thing we have is refrigerator or heat pump. A refrigerator or heat pump. This is also an important thing. Same working opposite to the heat engine. Here, say this is a heat pump. So what we are doing, we are giving the some work done here. We are transferring the heat from Q1 to Q2. So this is source, which is at temperature T1, and this is sink, which is temperature at T2 temperature. W is equals to Q1 minus Q2. Okay, so in this case the efficiency will become eta is equals to Q2 upon Q1 minus Q2. Okay, so this is all about heat pump and heat refrigerator. Then again we have one more thing, is Carnot engine, or we can say that Carnot cycle. Carnot cycle, PV diagram and TV diagram is most important thing here. Okay, this is a temperature where heat is going to add. This is isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. Here heat is going to reject. This is PV diagram. If we talk about TS diagram, so it becomes like square. These two are constant temperature. This is temperature scale. TS diagram to the entropy. This is constant two temperatures. So 1, 2, 3 and 4. Adiabatic expansion, sorry, isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. This is PS diagram for Carnot cycle. Efficiency, eta is equals to 1 minus T2 by T1, 1 minus higher temperature, sorry, 1 minus lower temperature to the higher temperature. Okay, so that is all things we have to remember in this particular chapter of thermodynamics. So if you have any query, so please ask in comment about that question so we can solve. Comment, your feedback is very important for us. Comment, please don't forget to comment. Please watch all the previous videos regarding the thermodynamics. I posted almost 7 to 8 videos on thermodynamics, and that is it about this chapter for JEE mains. I will post more videos at the time of advance, but if we particularly focus on mains today, then this particular thing, this whole 7 to 8 videos is more than enough. The most again important thing is notes. To make a notes from your hand and to revise it, to repeat it. Revision is most important thing in any type of competitive exam. So repetition of the material, repetition of the concept, repetition of the formula is most important. Otherwise you will forget them and you cannot remember at the time of exam. So please revise it in a continuous manner. That is all about today. Thank you for watching.